Okay, we're going to get started. I'm going to record the warm-up as well today since we have a couple people absent. Dakota. What are you? There you are. Since I changed seats, I forget where everyone is. Dakota, what did you get as an answer for number 1?
9.
9. That's the correct answer. So now tell us what you did. Whoops, I don't think I'm plugged in. I do this every day. There we go. Okay, tell us what you did first.
So I did 6 minus 3.
Okay, so let me just put some colored parentheses around 6 minus 3 so it's clear to everyone what you did first. Okay, so you got
3.
3. Good.
And then I did 9 divided by 3.
Okay. Did you do the 2 times 3 in that step also?
Yeah.
Okay. So 2 times 3 is,
6.
and 9 divided by 3 is,
3.
and then 6 plus 3 is 9. I'm going to take a volunteer for the second one. Jake, what did you get?
-7.
That's correct. How many of you got -7? Okay, good, good. Jake, can you tell us what you did first?
I did, above the 2, I did 4 times 3 was 12 first.
Okay, let me put parentheses around. Let me pause here a second because I noticed some of you were confused about how to handle this division bar. When you have something above a division bar, it's as if all of that is in parentheses. So when you do PEMDAS, which starts with parentheses, you should do things that are above any sort of grouping symbol. This division bar groups the top, the numerator, into its own problem that we have to address before the rest of it. So within that problem, Jake did the multiplication first, which is the correct thing to do. Okay, what did you do next, Jake?
I did 6 minus 12.
Good.
And got -6.
Okay, then what?
I did -6 divided by 2.
Okay.
And got -3. Then I did 1 times 4, got 4. And then -3 minus 4 equals -7.
Very good. Okay, if you did not get -7, make sure you copy down the work from that. Okay, your multiplication and multiplying and dividing integers tests have been graded, and they are in Skyward. I will probably be passing those back to you tomorrow. Because I have 1 still to grade. Okay, so today's lesson, we're moving into a whole new unit, expressions and equations. And today we're going to talk about evaluating expressions. Our objectives, first of all, you need to know what a variable is and an algebraic expression. We're going to talk about all the different ways that we show multiplication and division. And then we're going to be substituting for variables to evaluate expressions. I see I missed the T in the word substitute, if you want to stick a T in there. And then to determine whether expressions are equivalent. This is a big thing that will appear on PSSAs, is deciding whether 2 expressions are equivalent to one another. So all through our unit on expressions, we'll be looking at examples of that. Okay, moving on to the first page. A variable is a symbol, usually a letter, that represents 1 or more numbers. So usually most commonly used variable in algebra is x. The second most commonly used variable is y. The third most commonly used variable is z. And then we can also use any letter of the alphabet. You could also use a symbol to represent a variable. The point is that we have something that represents a number. So we have a missing number, we don't know what it is, we represent it with a symbol called a variable. An algebraic expression is a mathematical phrase with at least one variable. So that's what kind of sets algebra apart from basic math that we've been doing, is that we are using variables. So back in our unit on ratios and proportional relationships, there was a little bit of algebra in that unit because you wrote equations, y equals kx, remember that form? You wrote those equations where y stood for some number, x stood for some number, and you had to often figure out what those numbers were. Sometimes we can have mathematical expressions that are not algebraic. If you wrote an expression using only numbers, that would just be a numeric expression. Algebraic expression has to have variables. Here are some examples. A plus b has only variables. That's an algebraic expression. T plus 5 has a variable and a number. As long as it has one variable, it's an algebraic expression. And 6 minus b divided by c is another algebraic expression. The difference between an expression and an equation is what? Irene?
Expressions don't have an equal sign.
Yep, expressions. So you might want to add that in. Expressions do not have equal signs. And the definition says that it's a mathematical phrase. That implies it's not complete. It's not like a sentence. It's just a phrase. So expressions do not have equal signs. Equations do have equal signs. And we've talked about this a little bit already. You've been writing expressions and equations already. Our focus is now on perhaps more complicated ones. Okay, any questions about any of the definitions? Okay, let's go on to our second objective, showing multiplication and division in different ways. So if we want to multiply A times B, one way we could show it is this. Why might that be confusing in algebra to show multiplication that way? Carly?
Because the multiplication side can be a variable.
Yeah, the multiplication sign is an x. The most commonly used variable in algebra is x. So if we have a multiplication sign that looks like a variable, we're going to get confused about whether or not it's multiplication or a variable. So what are some other ways we could show A times B? Sky?
The dot.
With a dot. Okay, so we could do A times B like that. Jake?
Parentheses around the x.
Parentheses around the x.
Because it'd be A, parentheses, x, b, because it'd be multiplying.
Okay, but do we need the x if we use parentheses?
Oh yeah, never mind. It's a variable.
Okay, so we could just do parentheses A times parentheses B. That would work. Any other ways? Irene?
No parentheses because they're both variables.
They're both
A,
variables. If we just write AB, that means A times B. This is the preferred way to write a variable times a variable. Any other ways we could write A times B? Eve?
Could you do just one set of parentheses?
Yep, that's the other one I was looking for. You could do A parentheses B
Yeah.
or A parentheses times B, like that. Now, if you were using numbers, say you wanted to do 4 times 3, we're a little more limited. We can't write the numbers side by side like this. That doesn't mean 4 times 3, that means 43. So in numbers, we can't do that. When we're using variables, we should always write it this way. If you wanted to write 4 times A, the preferred way to write that is just 4A. It's better not to use a dot or parentheses. It's better to just use writing them next to each other. I have a special example down here. If you see something like this, A parentheses B plus C, parentheses tells us to multiply. So this is telling us we need to take A times what's in the parentheses. Order of operations tells us to do what's in the parentheses first. So we would be adding B and C and then multiplying the sum by A. There's also another way we can handle these kinds of problems that we'll look at later on, but I just wanted to expose you to that now. And we talked about up here already, when we write a constant, a number times a variable, it is usually written with no sign. So, example 2a means 2 times a, and if we have something like 5x, that means 5 times x. Okay, division is only shown 2 ways in equations. If we wanted to show A divided by B, this is the way you first learned how to express division. We have expressed division a lot this way, A over B. Any fraction is also a division problem. That's how we change fractions to decimals. This is the way that we use most commonly in algebra. We don't use a division sign. It's not confusing in the same sense that the multiplication sign is, but we usually show it by using the fraction bar. Jake?
Could you use a colon?
For division, no. We write ratios that way, but we never show division that way. That was a good question. Okay. Any questions? Okay, that gets us through kind of our definition section. Now we're on to our third objective already, to substitute for variables to evaluate expressions. To evaluate, what does the word evaluate mean, do you think? If it says evaluate each expression, what does it want you to do? Grace? To solve. So you could think of the word evaluate as meaning solve. So we're going to solve each expression. So we have 2p plus 7. The only way we can solve that expression is if we know what p is. And over here it gives us some values. It says to say that p is 2, n is 3, and s is 5. So we don't care what n and s are for this particular problem. We do care that p is 2. Remember that 2p means 2 times p, so I'm going to write 2. I could use any of the other multiplication methods that I wanted to use except the x. Let's stay away from the x plus 7. Order of operations gives me 2 times 2, multiplication first, and 4 plus 7 is 11. Okay, the next example actually has a dot used inside the parentheses, which would be unnecessary. We could also write this as p plus ns. And in fact, we could write it as p plus ns without any parentheses at all. So those parentheses and the dot are somewhat redundant, but we'll keep them there for now. So we have p, which is 2. So we have 2 plus n is 3. So we have 3 times s, which is 5. Doing what's in the parentheses first, I have 2 plus 15, which is 17. Okay, next slide is one for you to try, so take a second and do that, and then we'll talk about it. Okay, volunteer for this one? Adria?
I got 56.
Okay, tell us what you wrote out.
So n equals 3, so 3 in parentheses 3 plus t equals 5, so
Mhm.
5 times 7, because that's equals 7.
Okay.
And then I did 3 plus 5 equals 8 times 7 equals 52.
Good. When you are evaluating expressions, always write out the first step so I can see what you evaluated. This becomes more important in the next examples with negative numbers. And then funnel it down just like you do with order of operations problems. So I do want to see your work for these problems. Any questions? Okay. Next are some examples with negative numbers. This is where it gets a little tricky. Most people can handle the positive numbers. Negative numbers, sometimes you get mixed up with the signs a little bit. So here we have h equals 4 and x equals negative 6, which gives me 2 times 4 plus 5 times negative 6 plus 3. So when I'm dealing with negatives, I just have to remember all the rules, which you guys mastered quite well. The average grade on the multiplication and division test was an A, so you guys are pretty good with those rules. I'm going to do all of my multiplication and division from left to right. So I'm going to do 2 times 4 is 8. 5 times negative 6 is what? Negative 30 plus 3. Then adding and subtracting from left to right. 8 plus negative 30 gives me negative 22 plus 3 gives me negative 19. Okay, next problem. F is negative 4, N is negative 9. So we have 5 plus negative 16 over negative 4 plus 2 times negative 9. So I'm going to do all of my multiplication and division from left to right. So I'm going to do this and then this. Negative 16 divided by negative 4 is 4, positive 4. When we multiply or divide same signs, the answer is always positive. 2 times negative 9 is? Good. And adding and subtracting from left to right, 5 plus 4 is 9, plus negative 18 is negative 9. Okay, next slide has some examples for you to try. So go ahead and work on those, and then we will talk about them. Okay, most of you got the first one right. Only about half of you got the second one right. And it had a little trick in there, which I put in there on purpose. I wanted to see what you would do with that. So we'll be talking about that one. Devin. Is Devin here? No, there you go.
You're the second person that didn't
I know, I'm
here.
still looking, it's because I'm still looking for you back where Dakota's sitting, because that's where you sat before. Okay, what did you get as an answer, Devin?
53.
For the first one?
Oh, 4.
4, correct. Okay, can you tell us step by step what you did?
I sorted with 5 times 5, negative 5, minus negative 36.
Wait a second, let's just write what you substituted first. Don't actually do any of it yet. So you would have done minus 6 times,
6 times negative 6 minus 7.
okay, then what did you get for your next step?
Negative 25 minus negative 36 minus 7.
Okay, let me pause for a minute here. Here's where a lot of you got mixed up. You did this 6 times negative 6, but then you just wrote minus 36. This negative sign is still back here, so it's still minus negative 36. You could also think of this like this. You can think of this as plus a negative 6, and then you can do negative 6 times negative 6 to get positive 36, and then you would not have a minus and negative in this step. You would just have plus 36. You can handle it either way. The outcome will be the same. Okay, go on, Devin.
And then I changed, well, I did negative 25, and then I changed it to addition.
Good.
And plus 36 and plus negative 7.
Oh, you changed that one too. Okay, plus negative 7. Okay? Good.
And then I got 11 plus negative 7, and then
Which is 4. Okay, any questions about that one? Okay, I'm going to take a volunteer for the next one. Dakota.
I got 45.
Good, that's correct. Can you tell us what you did?
Okay,
How many of
so-
you got 45? Yeah, slightly less than half. Okay.
Can I write it? I don't even know how to.
Yeah, sure. Come on up. Audience participation today.
It's easier to try to instead of explaining it.
It is, you're right.
then I got that to equal -4.
Okay, wait, how did you get -4 from that?
I did 20 divided by 5.
But I have a question. So you have this -20 up here, and then you have your n, which is -5. Where did this negative sign go?
Oh.
So that negative sign, write that, that should still be in front. Because when you divide a negative by a negative, you get a positive, but we had this extra negative sign there, which makes it negative. Okay, so we had 3 negative signs total there. An odd number of negative signs when multiplying or dividing gives us a negative answer.
Then I did this time 8 times 5 and got 40.
Okay, the only thing I don't like about your 8 times 5 is using the x. I'd use a dot.
Okay.
Okay.
And then I added these
Mhm.
to equal 5
Good.
plus 40 and then made 5.
Good. Thank you very much. Any questions about that one? That was a tricky one. You also could have handled this as a -20. You could have changed this to addition right away because that's minus a negative. So you could have made this 20 divided by -5, which would have given you an answer of -4. Either way would have been fine. Okay, last objective is to determine whether expressions are equivalent. Are the following expressions equivalent? If the expressions are equivalent, then they should have the same answer when you substitute any number, which would have to be the same for both expressions, for x. Adria?
I used 2.
You used 2. Okay, let's try it with 2. So you had 2 times 2 plus 5, and you got
9.
9. Good. 4 plus 5 would give us 9. If we use 2 over here, we have 2 times 4.5, which is 9. So Adria tried a number. She tried 2, and they came out to the same answer, so therefore they are equivalent. My favorite number to use if I'm checking to see if expressions are equivalent is the number 1, because it's usually the easiest. So if I had, let me change colors here. If I used 1, I would have 2 times 1 plus 5, which is just 2 plus 5, which is 7. Usually if I use 1, I can just do it in my head. And then for this one, 2 times 1 plus 2.5 is 2 times 3.5, and that's 7. So no matter what number you put in for x, you are going to get the same answer every time. Okay, next slide is 2 for you to try. So you can pick any number you want to substitute in for x to see if the expressions are equivalent. Okay, read. Are these expressions equivalent? For the first one, for number 1. No. Okay, what numbers did you use to prove whether or not they were equivalent?
I used 2.
You used 2, okay, so we have 3 times 2 plus 3 is 6 plus 3, which is 9. Over here we have 3 times 5, which is 15. No matter what number you picked, you should have gotten no as your answer, because it would not have produced the same result. Eli, is number 2, are those expressions equivalent? You didn't get it? Let's see, check the next card. Jake?
No.
No? What number did you use?
1.
Okay, so we'd have, here's where using 1 is easy. We can just get rid of all the x's. We have 5 minus 2 minus 6. 5 minus 2 is 3, and 3 minus 6 is negative 3. 11 minus 2 is 9. And no matter what numbers you use, you should get that they are not equivalent. Great. Any questions before we do the exit ticket? Okay, your homework is going to be an evaluating expressions worksheet, and you will also have Get More Math. I put exit ticket cards. I think you guys already passed them back, so I'll get you started on that. And then I'll also pass back the homework. Please hold on to your exit tickets until everyone is finished.